given f from 0 to pi by 2 to the real numbers, and it is defined by f of x is equal to sin x, and g is a function again from 0 to pi by 2 to real numbers, and given by g of x is equal to cos x. We need to verify that whether f and g are one-to-one function or not. The statement 1. So f of x is equal to sin x. So differentiating with respect to x, f dash of x is equal to cos x. And here we can say for x belongs to 0 to pi by 2, f dash of x is equal to cos x, which is positive. Because in the first quadrant, cos x is positive. So we can say that the function f is increasing. And we know that when f is increasing or decreasing, a function is strictly increasing or decreasing, that function is one-to-one. So f is one-to-one. And similarly, and if we consider g of x is equal to cos x, and g dash of x is equal to negative sin x, and for x belongs to 0 to pi by 2 in the first quadrant, sin x is positive, which implies negative sin x will be negative. That is, g dash of x is less than 0, and hence we can say g is decreasing function. When the function g is decreasing, and hence we can say g is one-to-one, because either increasing function or decreasing function in one particular interval, the given function is one-to-one. So statement 1 is true. And coming to the second statement, f plus g, consider f plus g of x, which is equal to f of x plus g of x, that is sin x plus cos x. And here we can say that when x belongs to 0 to pi by 2, considering the boundaries, f plus g of 0 is equal to sin 0 plus cos 0, sin 0 is 0 and cos 0 is 1, so which is equal to 1, and f plus g of pi by 2, which is equal to sin pi by 2 plus cos pi by 2, and sin pi by 2 is 1 and cos pi by 2 is 0, which is equal to 1. And even if you consider in between value, f plus g of pi by 4, which is equal to sin pi by 4 plus cos pi by 4, 1 by root 2 plus 1 by root 2, that is 2 by root 2, which is equal to root 2, which is positive. So clearly we can say that the function is increasing and decreasing. Even if you see the graph, at 0 it is 1, and at pi by 2 it is 1, and at pi by 4 it is root 2, means 1 point, means the graph is increasing and decreasing, so which is neither increasing nor decreasing. So therefore we can say f plus g is not one-to-one. Therefore statement 2 is f plus g is one-to-one is false. So we can go with an option statement 1 is true and statement 2 is false. So we need to find secant square of tan inverse 2 plus cosecant square of cot inverse 3. And we know that secant square theta is equal to 1 plus tan square theta, and cosecant square theta is equal to 1 plus cot square theta. So here we can write 1 plus tan square of tan inverse of 2, and here cosecant square theta, cosecant square we can write 1 plus cot square of cot inverse of 3, that is 1 plus tan of tan inverse 2 whole square, and 1 plus cot of cot inverse of 3 whole square. So 1 plus tan of tan inverse of 2 is 2, 2 square, and again 1 plus cot of cot inverse 3 is 3 square. So tan of tan inverse x is equal to x, and cot of cot inverse x is equal to x. So we can write here 1 plus 4 plus 1 plus 9. The sum can be taken as 15. So we choose our option C. Two times cos inverse x is equal to sin inverse of 2x into under root of 1 minus x square. So let us consider x is equal to cos theta. So which implies under root of 1 minus x square is under root of 1 minus cos square, which is under root of sin square theta, which is equal to sin theta. And now 2 into x into under root of 1 minus x square, we can add 2 into cos theta into sin theta, which is sin 2a formula, sin 2 theta. So that we can write 2 cos inverse x, that is 2 times cos inverse of cos theta, and the other side sin inverse of sin 2 theta. Cos inverse of cos theta is equal to theta, where theta belongs to 0 to pi, and sin inverse of sin theta is equal to theta, for theta belongs to minus pi by 2 to plus pi by 2. So here 2 theta, here 2 theta must belongs to, or we can say 2 theta must lies between minus pi by 2 plus pi by 2. that is theta lies between minus pi by 4 and plus pi by 4. And here in this case, in the left side, theta must lies between 0 and pi. So from the both, so to satisfy this equation, we can say from A and B, theta must lies between 0 and pi by 4. And now we need to see theta is equal to, when x is equal to cos theta, when theta lies between 0 and pi by 4, so theta is cos inverse of x. Cos inverse x lies between 0 and pi by 4. Since cos inverse x is a decreasing function, and hence we can write x lies between cos pi by 4 and cos 0. So cos pi by 4 is 1 by root 2 less than or equals to x less than or equals to cos 0 is 1. So 1 by root 2 less than or equals to x less than or equals to 1, which is our option 4. So option 4 is the answer. So in a linear programming problem, that is LPP, so we use the objective function z is equal to ax plus by, which is always linear, where a and b are some real numbers. So we can say that statement 1 is true. And a linear programming problem, LPP, the linear inequalities on variables are called the constants. So here the variables are x and y. So the constants are like x is greater than 0, y is greater than or equals to 0, and some inequalities like px plus qy is less than some constant d, and all these are all constants. So we can also say this is also true. So in LPP we consider the objective function and the linear inequalities as the constants. Therefore statement 1 is true and statement 2 is true, which is our option 1. Given LPP, linear programming problem, maximize z is equal to 3x plus 4y with the constants x plus y less than or equals to 40 and x plus 2y less than or equals to 60 and x comma y is greater than or equals to 0. Say here is the point. This is a line equation. First line, x upon 40 plus y upon 40 is equal to 1. The line equation of inequality. So we can say this is 40 comma 0 and this is 0 comma 40. And another line equation, x upon 16 plus 2y upon 60, that is y upon 30, is equal to 1. So we can consider the line as so here is a point 60 comma 0 and here is a point 0 comma 30. This is the second line equation. And when we consider the inequalities, x plus y less than or equals to 40, where origin 0 comma 0 satisfies, so we can shade the region towards the origin. And coming to the second inequality, again origin is satisfying the inequality, we can shade the region towards the origin. And here we can see that there is a common solution. This is the polygon where we can see the vertices 0 comma 0, 0 comma 0 is 1 point, say this is O, A, that is 40 comma 0, and we need to find this point of intersection of these two lines. X plus y is equal to 40 and x plus 2y is equal to 16. Solving these two equations, we are getting y is equal to 20, which implies x is also equal to 20. So 20 comma 20 is the point, and say this point is C, 0 comma 30. So the points, say 0 comma 0, corner points we can say, because maximum or minimum will obtain at the corner points. So here the corner point 0 comma 0, 40 comma 0, and point B 20 comma 20, and point C is 0 comma 30. And profit function z is equal to 3x plus 4y. So let us calculate at 0 comma 0, z is equal to 3 into 0 plus 4 into 0, which is equal to 0. And at the point E, z is equal to 3 into 40 plus 4 into 0, which is 120. And at point B, 3 into 20 plus 4 into 20, which is 140. And at point C, 3 into 0 plus 4 into 30, which is equal to 120. And here we can say that the maximum is 140 at the point B 20 comma 20. So among the four options, option C is the answer. Given two statements, the statement 1, E and F are two independent events. Which implies that P of E intersection F is equal to P of E into P of F. Now let us consider P of E dash intersection F dash, which is equal to 1 minus P of E union F by De Morgan's law. And here we can write 1 minus P of E plus P of F minus P of E intersection F. That is 1 minus P of E and minus P of F and minus of minus plus, and P of E intersection F we can write it as P of E into P of F. So here P of you can take common. So we can write, or minus if I take common, 1 minus P of F and again plus 1 minus P of F. So 1 minus P of F into 1 minus P of E. 1 minus P of F is P of F dash into P of E dash. That is P of E dash into P of F dash. So P of E dash intersection F dash is equal to P of E dash into P of F dash. We can say that E dash and F dash are also independent. E dash, F dash are also independent. Option statement 1 is true. And coming to the second statement, two mutually exclusive events. Let us consider A and B are mutually exclusive events, which implies that P of A intersection B is equal to 0 since A intersection B is empty, with non-zero probabilities of occurrence, that is P of A is not equals to 0 and P of B is not equals to 0, which implies that P of A into P of B must not be equal to 0. But P of A intersection B is 0 and P of A into P of B is non-zero. So from this both we can say that P of A intersection B is not equal to P of A into P of B. So these two events A and B are not independent. Cannot be independent. So it is also given that cannot be independent, which is true. So statement 2 is also true. So statement 1 is true and statement 2 is true, which is our third option. Both the statements are true. Given that A and B are two not mutually exclusive events, which means P of A intersection B is not equal to 0. That is A intersection B is non-empty. And given that probability of an event A when event B is given, which is equal to probability of an event B when A is given. So we know that probability of an event A when B is given, which is equal to P of A intersection B divided by P of B. So here we can write P of A intersection B divided by P of B, which is equal to P of B intersection A divided by P of A. So P of B intersection A and P of A intersection B both are same, and it is given not equal to 0, so that we can cancel them and we can write P of A is equal to P of B. So we can say that option D is the correct answer. And here we can say since P of A intersection B is not equal to 0. Option D is the answer. 4. Given that A and B are two events such that A is subset to B, which implies A intersection B is equal to A, that is P of A intersection B is equal to P of A. And now let us consider P of A given an event B, which is equal to P of A intersection B divided by P of B. Here since P of B is not equal to 0. So that P of A given B into P of B, which is equal to P of A intersection B, that is P of A intersection B is P of A. So therefore we can write P of A is equal to P of A by B into P of B. Since P of B is not equals to 0, so we can say clearly that P of A is greater than P of A by B. That is P of A by B, that is A given B, is smaller than P of A. So which is our option 2? Option 2 is the answer. Here, Meera visits only one of the two temples. So, temple A and temple B in her locality. Probability that she visits the temple A is 2 by 5. And then we can say since she visits any one of the temple only, so we can write the probability of B is probability of visiting the temple B is equal to 1 minus the probability of visiting the temple A, that is 1 minus 2 by 5, which is equal to 3 by 5. So here we can write 3 by 5 is the probability for visiting temple B. And then if 1 by 3 is the probability that she meets her friend if she visits the temple A. So after visiting temple A, so to meet the friend, when she visits the temple A, the probability is given by 1 upon 3, and whereas it is 2 by 7 if she visits the temple B. When if she visits the temple B, the probability that she meet her friend is 2 by 7. So the probability that she met her friend at temple B. So we need to find the probability that Meera met her friend at temple B. And which can be given by, so 3 by 5 according to the base theorem, 3 by 5 into 2 by 7 upon the total probability we can take visits a temple A and meet her friend, that is 2 by 5 into 1 by 3, or visits the temple B and meet her friend, that is 3 by 5 into 2 by 7. So upon simplification, 3 into 2, 6 upon 35, or 6 upon 5 into 7, whole divided by, so here we can get 2 by 5 into 3 plus 6 upon 5 into 7. So 6 divided by 5 into 7 into, here we can write, here 5 into 3 into 7 is the LCM, so that will come to the numerator. So that here 2 sevens are 14 and here 6 into 3, which is equal to 6 upon, or 5 into 7 we can cancel here. So 6 into 3 divided by 2 sevens are 14 plus 18, which is 32. So again here 2 3 times and 2 16 times, 3 into 3 9 upon 16. So 9 by 16 is the probability that Meera meet her friend at temple B. That is 9 by 16, option 4. Let us consider the point A represents the complex number Z1 and point B represents the complex number Z2. These are the two complex numbers and represented with the points A and B, so that OA can be taken as a mod of Z1 and OB can be taken as a mod of Z2. Let us consider its resultant. Let us consider to be COC. C is the point with which represents the complex number Z1 plus Z2. Mod of Z1 plus Z2. Let us complete the parallelogram. So that OA and BC will be the same, mod of Z1. And here AC value and OB value will be same, that is mod of Z2. And OC is equal to mod of Z1 plus Z2. So from triangle OAC, we can say that by using the triangle inequality, sum of any two sides, that is OA plus AC, sum of any two sides must be greater than the third side, is greater than the third side, that is OC. OA is, that is mod of Z1, the length, and AC is mod of Z2, must be greater than mod of Z1 plus Z2. So this is the property we have, but it is given mod of Z1 plus Z2 is greater than mod of Z1 plus mod of Z2. That is mod of Z1 plus Z2 here, it should be smaller than mod of Z1 plus mod of Z2. But in the option 4, we have mod of Z1 plus Z2 is greater than or equals to mod Z1 plus mod Z2, which is not true. So we can say that option D is not true. But obviously the first, second and third are the properties of complex numbers. Mod of z1 plus z2, not mod, conjugate of z1 plus z2 bar is equal to z1 bar plus z2 bar, it is correct. And mod of z1 z2 is equal to mod z1 into mod z2, and conjugate of z1 z2 is equal to conjugate of z1 dot conjugate of z2. So all the three options are correct, but the fourth option is which is not correct. Okay,